Okay, page 25, continuing with risk and relative risk. You can pause and read question 39. Part A, what's the absolute risk of birth deformities in the two? So when we read absolute risk, that's the same as probability of birth deformities happening. So we've got 50 from one city and 15 from another. So altogether 65 birth deformities out of a total, if we add those two numbers together, 220,000. Calculating that as a decimal point 1, 2, 3. So just when you do that on the calculator, if you do 65 divided by 220, it actually comes up with 2.9545 written like that. So remember, this number is in standard form. It's a very small number. I can see from the fraction that it's very small. We need to move that decimal point backwards 4 places. It says -4. So it's 2.9545 times 10 to the power of -4. Move the decimal point. And then the 29, obviously we've rounded it to a 3. Right, part B. What is the relative risk? Now when we see relative risk, we know we have to divide two probabilities near the nuclear facility compared with no nuclear facility. So we want the probability of a birth deformity in the city near the nuclear facility, which is this first one up here described. We have 50 out of 100,000 divided by, compare that with the number of deformities, or the probability of a deformity not near it. Remembering divided by, using brackets around each probability, and when you work that out, it equals 4, probably rounded. So we can say you're 4 times more likely to have a birth deformity if you live in the city near the nuclear facility compared with living in the city that's not near the nuclear facility. Part C, and this is the same question but around the other way. So we've got the not near first divided by the facility, and this time of course we get 0.25. So we'd say you're 0.25 times less likely to have a birth deformity in the city away from the nuclear facility compared with the one near the nuclear facility. So when it says what conclusion can be drawn, we'll use the one from part B. You are 4 times more likely to have a birth deformity if living near the nuclear facility compared with living not near. Right, now if we go back to question 40 over here. This risk of failing the first year university course. Right, I find this one easier with a table. Now there's probably just enough room to squeeze in a small table up here. So some people used computer aided and other people used straight tutoring. Pass fail. So looking at the numbers, of the 145 students sitting the course using CAI, 120 passed, so that means 25 must have failed. And of the 150 sitting the course by tutoring, 138 passed, which means 12 must have failed. So there's some numbers that might help me. Now the absolute risk of failing the first year university course would be these people here all failed, 37 out of the total number of students, adding those two numbers together, 295. You can work that out as a decimal. .1254. Part B, the relative risk of passing the exam by CAI compared to tutoring. So for a relative risk, we need one probability divided by another one. Now we want the risk of passing the exam by CAI, which would be 120 out of 145. And we want to compare that with passing if you use tutoring. The probability of that happening is 138 out of the 150 people that use tutoring. And working out that division, we get 0.899. So 0.9 times less likely to pass if you use CAI rather than tutoring. Now this one is the same but around the other way. So we want this one first, probability of passing by tutoring, and we want to compare that with the probability of passing by using CAI, and this time we get 1.1. So I can see you are 1.1 times more likely to pass the course by using tutoring compared with passing using CAI. Not much of a difference in risk there. Right, question 41. Now we've got a bit of space here. Once again, we might want a table. Injury not. We've got two factories, factory 1 and factory 2. In factory 1, 24 out of 120 workers had an injury. In factory 2, 30 out of 150 workers had some form of injury. So that will be 120 there. That should be 96 in there. And altogether 270. Right, the absolute risk. So that's a straight probability having an injury. So the total number of injuries are 54 out of 270.2 probability chance of having an injury. Part B, the relative risk, so that means I want to divide two probabilities of having a work-related accident. We'll compare factory 1 with factory 2. It's not very clear from the question, but so the probability of having an injury from factory 1 would be 24 out of 120. Probability of an injury from factory 2, and working out that division, equals 1, which would mean an equal risk. So there's the same risk of injury in each factory. However, the company decides to implement an accident awareness program in factory 1. So now in factory 1, 16 out of 120 workers have some form of injury. So that would be 104. Factory 2 remains the same. So now what is the relative risk? It means I'm comparing two probabilities of having a work-related injury in factory 2. So that would be 30 out of 150 compared to an injury in factory 1. And working out that division. Right, working that in the calculator, 1.5. So you're 1.5 times more likely to have an injury in factory 2 compared with factory 1. So over here when it was 1, this was what we'd call an equal risk of injury. between the two factories.